Let us study about combination of resistors. Resistors are combined in different ways to obtain a desired resistance value. This combination is of two kinds primarily. The first combination is called as series combination, and second kind of combination is called as parallel combination. There is another way of combining the resistors, which is putting these two together, and that is called as mixed combination or a mixed arrangement. Mixed arrangement is not something which is different. It is basically combining series and parallel together. The reason as to why we want resistance to be combined is to obtain a desired value. To understand this, recall about money which has been circulated in the economy. Nowadays there are digital payments happening, but if we look at 10 years back, the transactions were mostly in physical format. The currency or the notes which was in circulation or which is still in circulation is of different denominations, like 1 rupee note or 1 rupee coin, and then 2 rupees, 5 rupees, 10 rupees, 20 rupees, and so on. Now suppose a person A wants to give a person B 17 rupees. Now the government cannot print all possible currencies. So this 17 rupees can be given as a 10 rupees plus a 5 rupees plus a 2 rupees combination. So by arranging money in different denominations, we can get the desired value. Similarly, in case of resistances, we cannot manufacture all possible values of resistances. So only certain standard values are manufactured, and the desired value is obtained by combining them in certain combinations. That is the need for resistors to be combined. Here we will look at the first kind of combination, which is called as series combination. To understand series combination, we will consider two resistors. The same argument can be used for more than two also. First, we will consider two resistances of value R1 and then R2. Across these resistors, a battery is connected, and let the voltage drop what the battery can supply be called as V. For example, think that V is like 12 volts. Now current I moves from the battery's positive, so that the same current I flows through resistors R1 and then R2. So this combination where the same amount of current flows through all resistances is called as series combination. Now since here current remains same, then the voltage will divide. That is, there will be a drop across the resistor R1 as well as across R2. Let us call the voltage drop across R1 as V1 and the voltage drop across R2 as V2. So this kind of a combination where the current flowing through all the resistances is same, but the voltage divides, is called as series combination. Basically here, this total voltage applied is equal to sum of the drops across each resistor. To make sense out of it, we can think of this like a combination of two pipes. Let us consider two pipes of different thicknesses, different sizes, and then across these pipes we draw water with the help of a motor pump. The motor pump in turn drops water from, say, sump. Now whatever water enters the pipe, let us call as P1, the same amount of water will enter through pipe P2 also. So here the same amount of water flows through both the pipes. So we can think of water to be like current. So in case of series combination, the same amount of current flows, same thing like water flowing through different pipes. This is called as series combination. The next type of combination is called as parallel combination. Again here we'll take up two resistors of certain values, and these two are arranged in such a way that across their common point, across the common points, we'll connect them to a battery and let this battery supply a voltage drop of V. Let a current I come out of this battery, and at this point the current finds two branches or two paths. Let resistances across this, or let the resistance be R1 and this be R2. At this point A, the current finds two branches. A part of the current goes through R1. Let us call that current as I1, and the remaining current flows through I2, R2, and that current is called as I2. Basically, I1 plus I2 is equal to I. At this point, say a point B, these two currents will combine, and again current I would enter through the battery. So this combination where the current divides is called as a parallel combination. In terms of voltage, the voltage drop across each resistor will remain same. That is, the drop across this resistor across points 1 and 2, or the drop across resistor R2, which would be these 2 points. Let us call the points as 3 and then 4. So drop across points 1, 2 will be same across points 3 and 4 also. So here voltage remains same but the current divides. So this combination is called as parallel combination. Again, you can think of examples of two pipes which are parallel. So when the pipes are parallel, the current will break into two parts. A third kind is called as mixed combination, where we take a case of the mixed arrangement where we have, say, a few resistors in series like this, and we have different branches like this. So this is one example of a mixed combination where we find some resistors are in series, and also here some are in series, but these two branches are parallel to each other. This is called as mixed combination. So these are the basic ways of arranging resistors.